The measurement precision of a predictor and an outcome is a necessary but insufficient condition for those two variables to covary with one another. And that is evidenced by the formula given here. This is the correction for attenuation formula, and it basically says that whenever our reliability is less than 1, that means we're going to observe a correlation that's smaller than what could be observed in the population if we had perfect measurement. So what we're getting is an underestimate of the relationship between x and y when our reliability for those variables is less than 1. So let's check out the formula and notice why that's true. The first term we have is the r, x prime, and y prime, and that is representative of the population or true correlation. And then the r, x, y on the numerator is the observed correlation in our sample. And finally, on the denominator, we have the square root of the product of the reliabilities that we observe in the study for both x and y. So rxx is the reliability of the predictor, and ryyy is the reliability of the outcome. And so substituting in those numbers would be a test-retest correlation. It would be an inter-rater reliability for both the predictor and the outcome, or the alpha, Cronbach's alpha for the scale. You could substitute those numbers in to the denominator of this equation. So let's think about what happens when we have perfect reliability. So when we have perfect, like a 1 for rxx and plug in a 1 for ryyy both, then when we take the square root of that, obviously is 1. And so the denominator cancels out altogether, and we just have our observed correlation, and that will equal the population or true correlation. So when we have perfect reliability, we don't have to worry about attenuation at all. However, you can go ahead and do this. Substitute in a 0.8 for rxx and a 0.9 for ryyy. So we're going below 1. And as soon as we do that, when we don't have perfect reliability, we are going to expect that the true correlation is going to be higher than our observed correlation. So you can see how that works in the formula. So again, whenever we have reliability estimates that are below 1, we can expect that our observed correlation will be attenuated, which means we will have less of a likelihood of detecting an effect that is existing in the population.